Hello, welcome to Shivajirao S. Zondale College of Pharmacy, Asangaon, Thane. Myself, Dr. Manisha Vite, Associate Professor of Pharmacognosy Department. Here we discuss in brief overview about high performance thin layer chromatography. Let's start with the introduction. An automated and sophisticated form of TLC is known as Hptlc and having superior and advanced separation efficiency and detection limits. TLC observing some limitations for qualitative and quantitative analysis of more complex herbal and synthetic formulation. High performance thin layer chromatography is robust, simplest, rapid and efficient technique in qualitative and quantitative analysis of compounds. The HPTLC is also known as flatbed chromatography or as planar chromatography. It is an enhanced form of thin layer chromatography. A number of upgradations did in basic TLC method and made to automate for increase and resolution between two components and for more accurate quantitative measurements. Automation is also helpful to overcome the uncertainty in droplet size and position when the sample is applied. The spot capacity also possible to increase by developing the plate by two-dimensional chromatography. Now let's see the history of HPTLC, when it was introduced, and when the first documentary evidence was published. In 1955, R.A. Kesar first introduced HPTLC. Halappa in 1973 introduced a nano TLC plate which was manufactured by Merck. First documentary evidence on HPTLC published in 1977 called as HPTLC High. In 2013, the concept was come HPTLC MS for enhancing the identification of compounds. On next slide, we discuss principle behind Hptlc and how the components were separated by Hptlc. As you know that it is an automated and sophisticated form of TLC, so principle remains same like TLC. The principle of separation is adsorption. The mobile phase solvent flows through because of capillary action. The components move according to their affinity towards the adsorbent. Then component with more affinity towards the stationary phase traverse slower and vice versa. Thus, the components are separated based on the affinity of the components towards the stationary phase and mobile phase. By using above principle, HPTLC used for the identification of constituents, identification and determination of impurities, and quantitative determination of active substances. Now we see different component of HPTLC and what's their role in separation. There are different components of HPTLC are as follows: sample preparation, selection of chromatographic layer, pre-washing of plates, conditioning of plates, sample applications, preconditioning, mobile phase of HPTLC, chromatographic development, detection of spot and scanning. Let's start one by one the details of each components. First step in HPTLC was sample preparations. It is prepared a highly concentrated sample solution in a suitable solvent which are volatile and polar in nature. As sample quantity is used for application on chromatographic plate was very small, be sure the prepared sample should be properly filtered with suitable filter paper and should not contain any undissolved material. The next component is the selection of chromatographic layer or the stationary phase. The stationary phase or chromatographic layer is an aluminum sheet coated with uniform thin layer. In HPTLC, the layer which are used as adsorbents available in the form of very fine particle size. Silica gel typically 200 micron of porous particles, that is 2 to 10 micrometer, with an average particle size of 5 micrometer. After preparation of plates with stationary phase, it should be pre-washed to avoid any distribution in formation of separated spot. The next component is the pre-washing of plates, and the plates are used or should use for proper clean to avoid presence of water vapor and volatile impurities. The plates were mainly washed with volatile organic solvents like methanol. The next point was conditioning of plates. Clean plates was conditioning by place in an oven at 120 degrees Celsius for 15 to 20 minutes. After preparation of plates and make the ready for use, let's see how to apply the sample on plates. Next is sample applications. Samples are applied onto the plate either as spot or as bands. The precision of the applied volume, the exact positioning and the compactness of the applications zone determine the quality of final results. To get good spot, the concentrated solution of the sample and standard solution should be used and spotted using a capillary tube or micropipette. The diameter of standard and sample spot should not be greater than 1 millimeter. Next is the preconditioning. Preconditioning of Hptlc chamber is required for efficient separation. It is the process in which the chamber is saturated with mobile phase components used for developments. When a highly polar mobile phase was used, preconditioning of plate is required, whereas for low polarity mobile phase, preconditioning of plate is not required. Now, main part of Hptlc and which play important role in separation of components from mixtures was mobile phase. The mobile phase use depends on various factors like physical and chemical properties of these substances to be separated, nature of the stationary phase use and mode of chromatography, etc. Commonly diethyl ether, methylene chloride, chloroform combine then individually or together with hexane as the strength adjusting solvent for normal phase Hptlc, and methanol, acetonitrile and tetrahydrofuran mixed with water for strength adjustment in reverse phase Hptlc was used. Depends upon requirement of experiments in different ratio of above solvents used to prepare mobile phase, which is helpful in separation. After plate preparation, mobile phase preparation, let's see how the chromatographic development takes place. The most common technique used for chromatographic development in Hptlc was linear development, where the plate is kept vertically in an appropriate container with a solvent or mobile phase. The mobile phase is generally fed by capillary action and both sides produce chromatograms. Now, last part of instrumentation was detection of spot and its measurements for calculation of results are as following. The Hptlc instrument has attached to computer and data recording devices. The development of spot is viewed as peak at wavelengths of selected UV regions. The height and the area of peaks are determined by the instrument and recorded as a percentage. Now move to next point, that is application of Hptlc. Hptlc is one of the most widely applied methods for the analysis in pharmaceutical industries, chemical industries, clinical industries, then forensic chemistry, biochemistry, cosmetology, food and drug analysis, environmental analysis, and other areas. It is due to its numerous advantages. For example, it is the only chromatographic method offering the option of presenting the result is an image. Other advantages include simplicity, low cost, parallel analysis of samples, high sample capacity, rapidly obtained results, and possibility of multiple detection. Hptlc was one of the simplest, rapid, and efficient technique for qualitative and quantitative analysis of herbal drugs. Hptlc mainly used for standardization of herbal drugs for investigation of the presence of possible adulterations or falsifications. It also used for the structure elucidation of herbal drugs along with the other chromatographic technique like gas chromatographies and high performance liquid chromatography. As a non-destructive technique, Hptlc more popular for quantitative analysis for plant extract and herbal drug formulations. Chromatographic fingerprinting is a crucial in the manufacturing of herbal products. Traditional chromatographic fingerprint analysis provides quantitative information. Hptlc is also used in analyzing the purity and the efficacy of many pharmaceutical preparations and dosage forms. Hptlc in natural products use an ideal screening tools for adulterations and is highly suitable for evaluation and monitoring of cultivation, harvesting and extraction processes and testing stability. At last, I can conclude from above presentation that applications of Hptlc for phytochemical analysis, biomedical analysis, herbal drug quantification, analytical analysis, fingerprint analysis, and Hptlc future to combinatorial approach. Hptlc MS, Hptlc FTIR, and Hptlc scanning diode laser made Hptlc a powerful analytical tool in the field of analysis. It is noteworthy that utilization of instrumental Hptlc towards the analysis of drug formulations, bulk drugs, natural products, clinical sample, foodstuffs, environmental and other relevant samples will increase in the future. Hope it is useful and informative presentation. Thank you.